Okay, we just derived the quadratic formula, and so now we're going to use it. We're going to use it to solve some quadratic equations. It's a powerful method because you can solve any quadratic equation using the formula. So here are a few examples. Number one, let's solve m squared plus m minus 4 equals to 0. And so this is based on this, ax squared plus bx plus c equals to 0. This formula is based on the equation being in this setup, so a 0 on the right-hand side. So in this case, if we modeled it off of there, a would equal to 1, b would equal to 1, and c would equal to negative 4. So m instead of x, m is going to equal to negative b, negative 1, plus or minus the square root of b squared, minus 4 times a times c, all over 2 times a. A in this case is 1, c in this case is negative 4, 2 times a is 1. Now we're just going to use order of operations to evaluate this. So m is going to equal to negative 1 plus or minus the square root of negative 1 times 1 times 1 is positive 1. Then you count the number of negatives we have right here. We have a 1, 2. So a negative times a negative makes this positive. 4 times 1 times 4 is 16. All over 2 times 1 is 2. So the answer to this is negative 1 plus or minus the square root of 17 over 2. So m is 1 plus the square root of 17 over 2, and 1 minus the square root of 17 over 2. All right, that's number 1. Number 2 is this. So number 2 is 4x squared. 4x squared minus 12x plus 9 equals to 0. So let's solve this one using the quadratic formula. This is in the right setup, so we'll just say x. A is equal to 4, B is negative 12, and C is 9. So x is negative B, negative 12, plus or minus the square root of B squared, negative 12 squared, minus the number 4 times A, which is 4, times C, which is 9, all over 2 times A. All right, so x is negative 12, which is positive 12, plus or minus the square root of negative 12 times negative 12 is 144. And then 4 times 9, let's see, that's 16 times 9. 9 times 6 is 4, 54, 9, 10, 11, 12, 13, 14. It is minus 144. Again, take a look here. 1 negative means this whole thing will remain negative all over 8. So we get x is equal to 12 plus or minus the square root of 144 minus 144 is 0 over 8. We get 12 plus or minus 0. Square root of 0 is just a 0. So we just get 12 over 8. So the whole plus or minus thing went away. And so we get 12 over 8. You could divide this by 4 over 4, right? So that would be 3 halves. This is interesting. This is a case where we had a quadratic, which gives us 2 answers. But in this case, we only got 1. And when that happens, this is called a double root or a double 0. So this is what our answer was here. Okay, we're going to hang on to that. I'm going to start making a list. For number one, our answers were m is equal to, maybe I'll just say, I'll write the answer right here. Our solutions were m is 1 plus or minus the square root of 17 over 2. All right. For 2, our answer was just x is equal to 3 halves. Okay. Let's look at number 3. Number 3 on our sheet. What did it say? It's x squared plus x plus 1 is 0. Okay. So this is ready to go. So we'll say A is 1, B is 1, and C is 1. They're all 1 this time. Okay. X is equal to negative B plus or minus the square root of B squared minus 4 times A times C all over 2 times A. And these are all 1s. So we get x is equal to negative 1 plus or minus the square root. 1 squared is 1 minus 4 all over 2. This is going to be a negative 1 plus or minus the square root of negative 3 over 2. Negative 1 plus or minus I square root of 3 over 2. So my two solutions here are negative 1 plus I square root of 3 over 2 and negative 1 minus I square root of 3 over 2. Okay, so we solved, in number 1, we solved a quadratic equation and we got two answers and they were both real. Let me grab my calculator real quick so I can get us a decimal answer so that feels better to us. Let's take this square root of 17 and see what it turns out to be. 1 plus square root of 17 divided by 2 is 1, oh wait, let me start. 1 plus the square root of 17 divided by 2 is 2.56. 2.56 about, and then we'll say 1 minus the square root of 17 divided by 2 is negative 1.56. Negative 1.56. Okay, so these were the two answers for that one, okay? Then in number 2, we solved this, and we found out that this quadratic equation only had one answer. And then we solved number 3, and we saw that this one had 2, but they were imaginary. So we got, right here, we got 2 distinct real roots. Here we got 1 real root or 0 or solution. Here we got 2 distinct imaginary. So what's going on here? Well, this is what's going on here. Two things. One thing is we can figure out what kind of answers we're going to get just by looking at the discriminant. So let me erase kind of the middle part where we did all this solution because I wrote down the gist of it. And let's discuss what is a discriminant. A discriminant is, it's this part. It is this part of the quadratic formula. So the discriminant is b squared minus 4ac. And so if you figure out what the discriminant is for each one of these, you can determine what type of solutions you're going to get. So if b squared minus 4ac is positive, you will always get 2 distinct real roots or zeros or solutions. If the discriminant is equal to 0, you will get 1 real root. If the discriminant is negative, you will get 2 distinct imaginary solutions or roots. Okay? 2 distinct. Okay, so right here, let's calculate what is b squared minus 4ac. I've erased it, so let's see. b was 1, minus 4 times a times c. A was 1, c was negative 4. So we had 1 plus 16. We got a positive 17. If the discriminant is positive, you're going to get 2 real distinct roots. That's what happened there. Those are real numbers. What about this guy? What was this guy's discriminant? It's this part right here. This ended up equaling 0. What happens there? You get 1 real root. And that is exactly what happened there. What is the discriminant for number 3? Number 3, it was 1 minus 4, a negative 3. The fact that the discriminant was negative means we would know going into this we're going to get 2 distinct imaginary roots, and that's what happened there. So on the last example, let's just predict what kind of roots are we going to get before we do the whole thing, and then we'll go find them. So let's look at, I don't know, did I call it number 3? Let's look at number 4. This last one. Number 4 is, by the way, you should commit the quadratic formula to memory. I realize we're in an online setting, but it's not doing yourself any service not to just memorize this, because later you'll be in a different math class and you're going to have to know it. So x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. If I was able to test you in a proctored setting, I would have a question on my test that said, write the formula down without using notes or anything. So you should, I really believe you should memorize this. Let's see, let's do the last one. I was gonna have us do, where did I leave that? Where's my little piece of paper? Oh, here it is. By the quadratic formula, let's solve it. 2x squared minus 3x minus 5 is 0. Okay, so let's see. I'm just thinking for a second. You know what? This one we could solve by factoring, we could solve by completing the square, and we can solve it by quadratic formula. Let's do quadratic formula, but first let's figure out what kind of answers we're going to get. First we'll say, what's the discriminant? What's the discriminant? It's b squared minus 4ac. What is a is 2, b is negative 3, c is negative 5. So let's go through and say, what is b squared? B squared would be negative 3 squared minus the number 4 times a times c. What is a? It's 2. What is c? It's negative 5. This is a 9. A negative times a negative makes a positive. This is going to be 40. And so 49 is positive. We're going to get 2 real roots. That's what we know going into this. So just for practice, let's solve this by, what should we do first? Let's solve this by quadratic formula, and then let's do completing the square for practice. Okay, ready? And you could also factor this. It's all going to give you the same answers. First quadratic formula, x is negative b, negative 3, plus or minus the square root of b squared, negative 3 squared, minus 4 times a times c, all over 2 times a. All right. A is 2, c is negative 5, 2 times 2. Okay, ready? Negative 3 is a 3, plus or minus the square root of 9, plus 20 times 2 is 40, all over 4. This is going to be 3 plus or minus the square root of 49 over 4. This is 3 plus or minus 7 over 4. Here's my two answers. 3 plus 7 over 4, 3 minus 7 over 4. This is a 10 over 4 or a 5 halves. This is a negative 4 over 4 or a negative 1. My two answers are 5 halves and negative 1. They're both real, and we knew that going into it because we had looked at the discriminant. So let's just record that. You know what? I think I would rather do factoring on this one. Let's do factoring just for practice instead of completing the square. Or we could do both. It doesn't matter. We'll do both. And if you don't want to watch it, you just don't have to. Let's see. How about if we did by factoring? This is a good one to factor. 2x squared, because you'll have to be able to do whatever method you're asked to do. I'm going to use AC method. A times C is negative 10. I want to come up with two factors that multiply to be negative 10 but add to be negative 3. So 5 times 2 is 10, and if I make the 5 negative, this plus this is negative 3, this times this is negative 10, that's going to work. So I need to rewrite my middle term here into what I chose that to be. 2x squared, I'm going to say minus 5x plus 2x minus 5 is 0. Or if you wanted to switch these and say plus 2x minus 5x, it wouldn't matter what order you write them down. Either way, it's going to factor correctly. So if we wrote it down that way, that's fine. What we could do here is group the first two and group the second two. Make sure you include that negative there. Factor out the 2x, leaving you with the x plus a 1. Factor out a negative 5, leaving you with the same factor, x plus 1. Factor out x plus 1, leaving you with 2x minus 5. Set each factor equal to 0 and solve. We'll get x is negative 1. Add 5, divide by 2. We get 5 halves and negative 1. Okay, lastly, real quick, by completing the square. 2x squared minus 3x minus 5 is 0. Move C to the right-hand side. If A is not 1, divide by A. Divide both sides of this by 2, because A is 2. So we get x squared minus 3/2 x is equal to 5 over 2. All right. Now, we need to add b over 2 quantity squared to this after you've done that division. So we're going to add negative 3 over 2 divided by 2. You can think of that as a 2 over 1. So negative 3 over 2 times the 1/2. Negative 3 over 4 is what b over 2 equals to. So we're going to add this squared to both sides. So we're going to say plus negative 3 over 4 squared. And if I go ahead and square, that's going to be 9 over 16. This will always factor into x plus whatever I see in there, quantity squared. Over here, I'm going to add these. I need to multiply this times 8 times 8. So that's going to be a 40 over 16 plus 9 over 16. So I get x minus 3 over 4 squared is 49 over 16. Take the square root of both sides, okay? The square root of the left is equal to plus or minus the square root of right. So we'll get x minus 3/4 is equal to plus or minus the square root of 49 is 7, the square root of 16 is 4. All right, I'm running out of room here. X is 3/4 plus or minus 7 over 4. 3 plus 7 over 4 is 10 over 4, which is my 5/2. 3 over 4 minus 7 over 4 is a negative 4 over 4. This is my negative 1. So you get the same answer whichever method that you choose to do it, although I will test you on knowing all of the methods.